Let us take one typical question. The question is from the black body radiation. The question is like this. A black body is at a temperature of 5760 Kelvin. The energy of radiation emitted by the body at wavelength 250 nanometer is U1, at wavelength 500 nanometer is U2, and that at wavelength 1000 nanometer it is U3. Given that the Wein's displacement constant B is 2.88 into 10 power 6 nanometer Kelvin. Now the question is, which of the following relation is correct? U1 is greater than U2. Second condition given is U2 is greater than U1. Third is U1 is 0, and the fourth one is U3 is 0. Now let us try to solve this question. Now if we see the data, clearly we can make out this particular question is from Wein's displacement law. Now the many clues are there given in the question which leads to that conclusion. Anyway, now according to the Wein's displacement law, the wavelength corresponding to the maximum emission of radiation is given by the relation lambda m. So we can say from Wein's displacement law, what we have is maximum wavelength is inversely proportional to the absolute temperature. So therefore we can say the wavelength corresponding to maximum emission of radiation is some constant. Now it is given that out here we have B is given as 2.88 into 10 power 6. This is what is given, and T is given as 5760 Kelvin. Therefore the wavelength works out as this wavelength lambda maximum wavelength works out as 500, around 500 nm. This is what we can say from the given data. Now if we try to plot the spectral energy distribution curve, then what we can see is, I am plotting it here, it is something like this. Here we have wavelength and here we have the spectral energy. In our case it says the energy of radiation emitted at 250 nm is U1. So here we are plotting U, let us say. Now the curve is a bell curve which goes to the maximum. From the calculation it says this is the maximum in the curve, and that happens at 500. This is what we have calculated. Now at 500 it is U2, therefore this will represent U2, and 250 it is U1. If 500 is here, somewhere here 250 is. So what we can say is, somewhere here if I say 250 exists, then the corresponding is U1, and U3 is 1000. So U3 is somewhere here. If I say, if I plot 1000 here, then what we observe from the graph, where does it lie? So clearly the graph shows the relation between the three energies. So, to sum up, what I can say is, once we calculate the maximum wavelength, then we can locate where the remaining energies lie. So, from the graph, what we can say now? From the graph, it clearly shows U1, U2 is greater than U1 and what we have? U3 is less than U2. So, what do we have here? What we can state? U2 is greater than U1. U2 is greater than U3. So, now the given relationship. Now, in the given choice, what we have? U1 is greater than U2? No. First choice is ruled out. Second, U2 is greater than U1? That's very right. And third, U1 is 0 is ruled out, U3 is 0. So, the answer is choice B. This is exactly how from the graph of the spectral energy distribution we can find out the relation between the energies at different wavelength.